Hello, and thank you for attending my presentation. I know there are a lot of good presentations, so I so much appreciate you attending mine. I'm going to talk to you today about taking GitOps automation to the next level. But first, just let me introduce myself. My name is Tracy Reagan. I am somewhat of a microservice evangelist. I'm super passionate about configuration management and continuous deployment, which is why I have interest in GitOps. I am the CEO and co-founder of DeployHub. I was listed as a tech beacon last year in DevOps Visionaries. I'm a founding board member of the Eclipse organization back in the day, and I'm also a board member of the CD Foundation. I'm also a DevOps Institute ambassador, and I have been doing what we call DevOps now for my entire professional career. So to really understand what I'm talking about when I'm talking about bringing GitOps, upping the automation level in GitOps, I think it's important to start at the beginning. So in the beginning, we started hearing about GitOps. It kind of followed infrastructure as code and this concept of operation by pull request with leveraging Git with an operator. And in the beginning, it was used by teams because they needed an immutable deployment process, and they were containerizing their applications and moving into the cloud, and they wanted to make sure nothing was tweaked in the process, manually in particular. So this idea of creating this hermetic or immutable deployment was very, very interesting, and infrastructure as code was sort of doing that, and that's how that's really where I first started seeing GitOps. And it was perfect for containerized apps. It really solves some problems. And when I say containerized apps, I'm talking about taking a monolithic software solution, an application, that is compiled and linked with all of its dependencies, and then putting it in a container with all of the dependencies that it needs to run. This is different from microservices, and we're going to kind of dig into that. But the idea of containerizing your apps kind of insulated it from external changes, and that's how many companies still today are starting to migrate into a cloud environment. So let's just talk about why it's brilliant, why GitOps was such a simple, brilliant solution. So I'm sure because you're at this conference, you probably know this, but some of you may not. So I'm just going to go over the architecture of it. In a GitOps environment, you have your cluster and you have your application running in your cluster. And in the cluster, you have a GitOps operator. A GitOps operator monitors a Docker registry or a registry of some sort to retrieve containers from. But it gets its information from your Git repository. So in a GitOps model, you have two repositories. You have your code repository, and in this example, I have the hipster store code repository, and then you have an environment repository where you store your deployment file, and this could be a Kubernetes deployment file, or it could be a Helm deployment file. But the important thing to understand is it's declaring a desired state. And instead of you having an imperative script, you have a declarative one that says, this is the state I want. And the GitOps operator delivers it for you and understands how to do that. It looks at things like the SHA, and it determines what Docker registry, what container you need to pull from that registry. So it's the end user has to update the scripts and push it up to the repository, and then your regular pull request and your approvals and merge occur. Once it's in the environment repository, the GitOps operator monitors that and makes sure that the desired state is achieved at your cluster level. So a developer makes an update to the code, commits the changes to Git. A new container image is created and registered. This can be done manually or via a pipeline process, which creates a new container tag. Then this tag is unique to that specific container. The developer updates the deployment YAML file with that new tag and commits it back to the Git environment repository. The GitOps operator sees the new commit, updates the cluster with the new container. And as I say, that was brilliant. And the solution is immutable. It is airtight. It is hermetic. A manual tweak to the cluster is overlaid. If a manual tweak to the cluster occurs, somebody goes out there and does something manually or through some kind of CLI or interface, the cluster overlays that. The cluster says, oh, I'm out of sync. I'm going to bring you back into the desired state. So everything you do, everything you track is done by this check-in process, which is operations by pull request. So it had big benefits, and it has big benefits, because without a change in the way we work, everybody pretty much knows how to submit a change request, or I'm sorry, submit a pull request. We were able to create a hermetic deployment process that didn't require a whole lot of learning and was super easy. Just checking in the code or triggering an action, and GitOps has created this airtight deployment process for us. With this process, one of the benefits is the governance around it, the auditability, and we have a high level of confidence, like pretty much 100%, that what is stored in Git is represented and running out in the cluster. So if you needed to compare what was happening between two clusters, you can look at the YAML files and see what changed between any two YAML files. So it's a super simple solution with super big benefits. Manual tweaks and imperative scripts were completely eliminated. And that, in essence, was the goal of GitOps, and it's the goal of infrastructure as code in general. So the question we have to ask ourselves, can GitOps scale? And I think we all know that from an architecture perspective, it can. It can scale to as many clusters as needed. A GitOps operator is going to run in each cluster, and it manages that cluster in particular. If you have hundreds of clusters, you're going to have hundreds of operators, and they're doing their job for that particular cluster. So scaling across the organization is, again, one of the benefits of the GitOps architecture. But we have to start thinking about how it scales on the human side, what interaction a human needs to take, what steps they need to take to make GitOps work. And this is really the premise of this discussion, is what's the next level of automation? And to understand why we need it, we need to see how scaling is impacted when we start using GitOps across a pipeline, and again, when we increase the number of YAML files when we start using microservices. So let's just take our first scenario where we have a containerized application. In a typical GitOps implementation, you are going to have a branch of your YAML files to support dev, test, and prod. Each environment may contain separate variables or separate definitions that are unique to that environment. Development and production may not be the same. In some cases, you may just have one trunk, and you may have multiple YAML files that the operator interrogates to try to sort out what variables need to be applied to that cluster based on what state it's managing. So in this case, in the simple case, we've already broken up our simple single YAML file into 3 YAML files, one to support dev, test, and prod. And this is a very simple pipeline. Many of you probably have many other steps in your pipeline. We have companies that support many, many different testing clusters, and they have phases of testing that they go through. So in this simple pipeline, we have 3. You could have multiple ones just for your single container running across your different pipeline stages. So let's take this journey one step further, and let's go into the microservices world. We began our journey with a containerized application, but now we want to deploy microservices. And as you know, microservices are the process of taking your container, your monolithic application that we stuck in that container, and decomposing it. And everybody knows that breaking up is really hard to do. And it creates more complication in the pipeline and in our GitOps model. And the reason why is the number of YAML files. And I'm always going back to this is a discussion around scaling the human part of GitOps. And when we have more YAML files that we're managing across a pipeline, it potentially makes it more difficult for we DevOps humans to manage it. So let's take a look at a simple, very simple example. We have an online store company here. They have two front ends. They have a candy store and they have a hipster store. The candy store and the hipster store, they share services. They use the same shipping, the same cart, and the same payment service. But the way that they've implemented this is they've added the candy store has a cluster and the hipster store has a cluster, and they each have their own GitOps operator. So when we use a GitOps model, we are going to have a candy store repo for this is just for one state for production. And we're going to manage the YAML files for the cart, the shipping, and the payment. And in the same way, we're going to do that with the shipping, payment, and the cart service in the hipster store repo. So there's 4 YAML files per state. So as you can see, we begin to start having the need to manage many YAML files for many different environments. So in this case, we're managing 15 YAML files for this. Now, when we were doing it in a single container, we had 1 YAML file for the entire container. When we start breaking it up, we start breaking up the number of YAML files we need for these different services. And then we add the pipeline. We end up with, a good number of YAML files that we're having to manage in this GitOps process. So I know the point, lots of YAML files. So as we expand into microservice architecture, we're adding exponentially the number of files we're managing in Git, and that can be a human problem. And even though we consider this as a pull process, a human is pushing it. They're pushing the updates into this environment repo or in a segmented environment repo, and they're managing merges. So there's work to be done there, and this part is manual. And in our world of automation in the CI/CD pipeline discussion, we don't want to do things manually. We want to automate everything. And while the actual deployment, once we get the YAML file updated into the correct Git repository, while that then is automated, the process of getting it to that point is manual. So yes, it took me a bit to get there, but now we've arrived in my discussion about how we need to and why we need to automate more of the GitOps process. And now I'm going to talk about how. So I'm going to introduce to you an open source project called Ortelius. Ortelius is an open source project incubating at the CD Foundation. It's a microservice management platform that versions and tracks microservices, their blast radius, and inventory across clusters. This provides you a proactive view of your microservice architecture as it changes over time. Our mission at the open source project is to really simplify the adoption of microservices through this world-class microservice management platform. And I'm very proud to say we have an amazing, diverse group of committers that come from everywhere from Nairobi to South Africa to Pakistan, of course, India and the United States, Germany. We're all over the place. So let me talk to you about what Ortelius does today, because I want to explain to you what we're looking at doing for addressing this problem of automating that GitOps, the human side of GitOps. So right now, the way Ortelius works with the pipeline is it gets woken up at the time that a container is, a new container is registered. So let me tell you how Ortelius interfaces with the pipeline today. Ortelius can support your pipeline, and it gets triggered at the point in time that a new container is registered. That's when we get triggered. And when Ortelius gets triggered, it captures the SHA, and it uses the SHA as a unique identifier for that particular container, and it creates a version of that container, or what we call a component. could be anything, quite honest. It doesn't have to be a container, so we call it a component. But if it's a container, we capture the SHA and we map all the relationships it has to any of the consuming applications. Now I'm not going to get into tell you how we do that. It's pretty simple, but the point is that we can version that kind of information. Once the deployment occurs, we are notified, again, we track the deployment, we are notified where it went to. We would call Helm, in this case, Helm or Spinnaker, and we would get feedback that says this microservice now has been installed into this cluster. So Ortelius listens and tracks the inventory across all clusters. It has a full set of APIs that we can work with, and it has something that I consider very important to this particular problem set, which is this data store. Because what we are creating is a central database of configuration management data that contains what's needed to automate the update of the YAML files. So in other words, Ortelius hoards metadata. And it creates the central catalog of microservice configuration management. It also separates the data from the definition and store keys value pairs based on environments. And right now what we do is we generate a Helm overrides file based on the environment, and then it calls Helm to do the deployment using that override file based on the environment it's being deployed to. Ortelius stores the things like the SHA and the image tag and uses that to create a new version for that specific container. Now, not necessary for this discussion, but I think it's important to know that in a microservices world, you have to think about we are doing linking very different than in monolithic. In the monolithic approach, what we did was we would compile and link our application, and any external library we would use, we would link it, statically link it into our binary, our jar file, or WAR file, and push that out. In a microservices world, we don't do that. The linking is done via APIs at runtime. So when Ortelius starts managing this kind of data as pushed across the pipeline, what it does is it says, hey, I have a new version of a microservice, which means that any consuming application has a new version. So it doesn't just version the microservices or the container, it also versions the application that's consuming that particular service. So this is the kind of the data that we'll use to automate what we like to call the human side of DevOps or GitOps. So there's two ways that we're looking at. This is a project we will be working on in the early fall. We're right now gathering our requirements and really understanding a needs analysis and where this should be, how this should be implemented. But these are our thoughts for now. So there's two generic ways that we can automate all the steps that a human does to make GitOps work, and put that into the pipeline so that you can have a GitOps model that's driven by your pipeline. The first way is Helm and GitOps. So if you have a Helm GitOps operator, what Ortelius will do is very similar to what it does today. It will generate the values for the YAML file for the correct environment, for checking that into the environment repository. Once it's generated, it would automate the check-in of the new YAML file. After the check-in, then, Ortelius will issue a pull request to stage the change. And if allowed, it can automatically do the approval. Now, what that does is it replaces a human having to do all of those extra steps. We don't necessarily need a human to do it. We just need to get that information into Git. So we want to automate those steps. Now, the second way is a Kubernetes deployment YAML file. It's very similar. Ortelius would read the existing deployment file and update the new values based on the environment it's going to and where it needs to be checked into. After the check-in, Ortelius would issue the pull request to stage the change, and then it would automate the approval if it's allowed. Automating the approvals is something you'd have to make a decision to do. You could certainly make a human do that. But when we do that, we start interrupting the CD pipeline. And I know that production releases and continuous deployment's not consumed by every single user of a CI/CD pipeline. It needs to be. It should be a consistent, repeatable process across the pipeline. The way you deploy to development should be exactly the same as you deploy to test and to production. And with a GitOps model, we have an opportunity to actually do that. The challenge will be getting that automation so that we can drive it into the pipeline, allow the CD pipeline to execute the process. And these may be events at some point. So we would have an event called Ortelius to create the YAML file. Another event would create the pull request, and do another event might do the approval. So we're moving into a very new world of DevOps and a CD pipeline, and how we can actually change the way we do work. And when we do that, we need to make sure that the production updates are handled through the pipeline in the same way as dev and test is. I know some companies are doing it quite well, and tools like there's Spinnaker and Harness. There are tools out there that are supporting this process, but they're few and far between that actually do a production rollout within the CI/CD model. There's often a wall, and what we want to do is break down that wall, and GitOps definitely has the potential of doing that. So how would it look after the fact? How would we have a GitOps in Ortelius in the pipeline with GitOps? We'd look very similar. We would still do a container. We'd still be triggered based on a new container being registered. We'd still grab that same information. We're already hoarding that now. We track that because it's critical for us for versioning that container. Then at some point, there would be a scheduled or on-demand trigger of the deployment process. At that point, Ortelius would generate the YAML file, either a Kubernetes YAML file or a Helm YAML file. And we would do we would trigger the pull request and potentially the merge and the approvals. And then, of course, we would continue listening, getting that feedback from the GitOps operator of what actually got deployed, and ensuring that we know what the correct inventory is for that particular microservice. And then we can continue giving you the great maps that we have that shows how an application version changed and why, and show you what the blast radius is of anything that gets pushed through an operator. Okay, so I'm going to quickly jump out of my PowerPoint, and I am going to show you a little bit about what Ortelius looks like and how we're going to do that update. Okay, so Ortelius is broken. It says Deploy Hub, but I'm only showing you the Ortelius, the open source parts of Deploy Hub. Deploy Hub is based on the Ortelius open source project. We talked about components, and I talked about applications. Components for this discussion is the most important, but I'm going to show you how we roll up information. So we'll start by looking at what I like to call our hipster store. When you implement Ortelius, you as an application team define your package in the same way as you would in many different kinds of deployment tools. You define what you want to deploy. What we do with that is we track the dependencies. So you can take a look at this is the application-based version of our hipster store 4th of July sale. And you can see that it is consuming the cart service. And the cart service it's using is GC6. Here's GC6. This is the base version. When it rolls out the base version. This is what the Helm would deploy this. Now let's go and look at the components. Components change, and if you're working in a service-oriented architecture, or if you're not and you are using clusters and you're still sharing components across teams, which means you have somewhat of a cluster sprawl and you have the same cluster running, the same component or microservice running in different clusters, you need to understand the sprawl and what I like to call the blast radius. So that's primarily the solution that Ortelius is providing, is so that you can see if you need to update the cart service, where you need to update it to. So you see we have the base version of the cart service. We have the GC6 version of the cart service that our base version application was consuming. And now we have a new version of the cart service. This is the kind of information that we're tracking and how we would generate those, the YAML files for our GitOps approach. In this case, you can see that This cart service is stored in Quay. For this version, we grabbed the digest and the tag, and in fact, we used the tag as part of our versioning schema. You can see that we used the name of it. This was pushed via CircleCI workflow, and it uses Helm, and it uses the cart service Helm chart. This is the data that we use to, oh, and then over here is where we store those key value pairs that map to an environment. This is, and we also track where that cart service has been deployed. In this case, it's been deployed to the Hipster Store cluster, a CI/CD cluster, and an initial repo cluster. In our GitOps model, we would take this information, we would do very much what we're doing today, except instead of pushing it to using Helm, we would have a GitOps action here. And that's what would do the lifting between doing the check-in and the merge to get it up to the correct GitOps environment repo. Over here is what you see as the blast radius. Remember, I told you that in the new world, if you update a component, you need to also update the version of the application. Well, in essence, that's what we're doing. So in our GitOps world, we would initially grab the information by grabbing the SHA, basically. We would sit on that until it was deployed, but we do create the relationships at that point in time. So in this case, we know that 3 applications are going to be impacted if this cart service is updated to the GitOps repository. This is your blast radius. Now, at the higher level, what we do is, remember, we started looking first at the Hipster Store 4th of July sale. Well, now we have a new version because the cart service got updated. And if we take a look at that new version and we take a look at it in the from a general perspective, we can scroll down, and from the application perspective, the application team can say, oh, okay, we had a problem with our Hipster Store application because the cart service was updated. Now, regardless of how it's updated, whether it's being pushed in a more traditional way or in a GitOps way, we can start tracking that kind of information. And in essence, that's what Ortelius is doing. It is creating the bill of material reports, it's creating difference reports, and it's creating your blast radius. So again, thank you, and I want to thank Weaveworks and Red Hat for hosting this GitOpsCon and inviting me to speak. I very much appreciate the opportunity to talk about the Ortelius open source project and how we're thinking to enhance Ortelius to support that GitOps model and automate the work that humans are having to do now, in particular in a microservice environment where you have lots of YAML files. If you want to learn more, if you want to contribute to the Ortelius project, we'd love to have you. You can go to ortelius.io. And you can also check out our GitHub repository at github.com/Ortelius. And if you're wondering where we got the name, Abraham Ortelius, he was the first person to create a world atlas, and he did so in a very open source way. He gathered information from other cartographers, and he put together a massive map and gave all those other map makers credit for it. So that's pretty much an open source community. And we are making maps. We're making maps of microservices running in clusters and tracking their relationships. And we do that outside the cluster. Keep that in mind. We are sitting above all the clusters and creating a centralized hub of data, of metadata about deployments. And the GitOps information will be one of those data points. You can follow Ortelius at LinkedIn, Ortelius-open source, or follow us on Twitter at OrteliusOS. And you can follow me at Tracy Reagan, and there is my LinkedIn, tracy-reagan.-oms. If you ever want to chat about this, please reach out to me, and I would be happy to send you a calendar invite so we can do a 15-minute chat. I would very much love to get your feedback on the needs for the automation part of the front end of GitOps. Thank you.